In this video, we're going to use properties of logarithms to solve this exponential equation. We'll also solve it by graphing, using a graphing calculator. Now let's look at some of the main properties of logs. I used these in another video. Main ones are the log of a product of two numbers or two expressions is equal to the sum of the logs. The log of a fraction is the log of the numerator minus the log of the denominator to whatever base you're using. And we have this one here. The log of some number to a power is equal to the power times the log of that particular base or number. And also this one here, if you have m equal to n, and here they have to be positive numbers, m and n are positive, I can take the log of both sides to the same base, and I'll still have equality. So here's what we'll do for this one. I'm going to take the log of both sides, and I could use any base. The most convenient one is either log to base c or natural log or base 10. I'm going to use the natural log. I have two expressions that are positive, and they are 3 to the 2x and 7 to the x plus 1. They're positive. I can take the log of both sides. I still have equality. So this is what I wind up with. And then again, from the properties of logs, if I have a log of some expression, in this case it's 3 to the 2x to a power, that power can be written as a coefficient. So this can be written that way. Same thing over here. The exponent here is x plus 1. That can become a coefficient. And make sure you put parentheses here. Otherwise, when you multiply it, it's not going to come out because you have to multiply both the x and the 1 here. So maybe write this as 2x, or leave it the way it is, I should say. And then on this side, I just multiply through by the log of natural log of 7. So this becomes x ln of 7 plus, and ln of 7 times 1 is ln of 7. And now I'm solving for x. So I want the terms that have an x on one side. So let's do this. This will be 2x ln of 3. And then the x ln of 7 comes over. We're adding the opposite to both sides. So it's just bring it over and just change the sign. So it's minus x ln of 7. And that will equal 2 ln of 7. So here I have the x's on one side here. So for this one here, then I'm just going to factor out an x. This will be the next step. Factor out an x. Put your parentheses, that leaves me with 2 ln of 3 minus, taking out the x, so that leaves me with ln of 7 equal to ln of 7. Now, in the next step, here I have a coefficient of 2. I'm going to make that into exponent, so that's going to come here. Make it 3 squared. So this will just become ln of 3 squared, which is 9, minus ln of 7. And that will equal to ln of 7. Now at this point, I could just go ahead and divide both sides by this expression here. And you would have ln of 7 divided by ln of 9 minus ln of 7. And either you can leave that as your answer, or you can use your calculator and get an approximation. But what I'll do is this. I have a property of logs that tells me if I have the difference of two logs, I can write that as the log, in this case natural log, of, in this case 9 over 7. And that will equal to ln of 7. So now I have x times ln of 9 over 7, that's just a number, is equal to ln of 7, that's just a number. So then I just divide both sides by this quantity right here. It's just like if you had a 2x equal to something, you divide both sides by 2. Well, in this case, this will be x is equal to. So dividing both sides by ln of 9 over 7, it cancels it over here on this side, just leaves me with the x. And on the right side, it'll leave me with ln of 7 over ln of 9 over 7. Now this is actually your exact answer. If they want an exact answer, it's the natural log of 7 divided by the natural log of 9 over 7. Natural log of 7 divided by natural log of 9 over 7. Now you can leave this if they want the exact answer. That's it. If they want an approximation, then you simply use your calculator. Take the natural log of 7 and then hit your divide, and it's ln of 9 over 7. Make sure you put this in parentheses when you use the calculator to make sure you get the correct answer. And this should come out to 7.743. You round off to 3 places. So this is an approximation to 3 places. You can round it out to 2, 1, whatever they tell you. That's it. Now the other way I want to do this is graphing. So what we'll do, on your graphing calculator, obviously you have the y1 into the function and you graph it. So in this case what we're doing is y1 is going to equal to, let's take this over to this other side, and this will be, and we write this as 3 to the 2x minus 7 to the x plus 1. So basically what I have then, I can rewrite this equation. It's still the same equation. It would be 3 to the 2x minus 7 to the x plus 1 equals to 0. So we want to find the value of x so that this expression is equal to 0. Well, that's going to be the same solution to this equation here. Now if you're looking at a graph, the expression or the value that makes this 0 is what is called the 0 of the function. So if you graph this and find the zeros, this one's only going to have 1. That's going to be the solution to this equation. So let me go to the calculator here. And here I have the function already entered. y1 is equal to 3x. I'm sorry, y1 is equal to 3 to the 2x minus 7 to the, and then I have parentheses there, so the calculator reads it correctly, to the x plus 1 here. And then I said graph, and this is what it looks like. So you can see the graph appears to go, approaches the x-axis this way to the left, and it comes down, and then it goes up, and you can see it crosses right there. So what is that? That's 1, 2, 3, 4, 5, 6, 7. So somewhere between 7 and 8, it crosses the x-axis. That's an x-intercept. Remember, for the x-intercept, the second component is always a 0. So you can have an x-intercept of 1, 0, 2, 0, 3, 0, 0, 0, and then over the origin. If it crosses the origin, the graph would have a 0 at 0. The x is 0 and the y is 0. So what we'll do is, to do it on the graphing calculator, we go second and then calculate. And we were looking for the 0. So hit 2. And what's a left bound? Okay, so you can see that this is between 7 and 0. So I need to pick something close to 7 or less than 7. So let me go 7 point. This looks to be somewhere in the middle, so I'm going to pick 7.02 and so on. You can see it there. I hit enter, and then it asks you for a right bound. Now for the right bound, I want anything to the right of this point where it crosses the x-axis. Well, we can see it's between 8. So let's go to 8. So hit the arrow here, and let's just pass 8 and make sure. Okay, so we're larger than 8. Now we hit enter. And now it wants you to give a guess. Well, here you can just ignore this and just hit enter. And notice it tells me 0. So actually the point here is 7.742930 and 0. So the fact that it gives me y equal to 0 tells me that this is a 0. So my solution is right here. The solution to the equation, which is the 0 of this graph, is x equal to 7.7429 305. And of course, you can round it to whatever places you want. Thanks for watching. We'll see you next time.